Right, quick video lesson on fractions. This picture shows how fractions work in some way or other. We have here some bars, which you might want to imagine as being chocolate bars, what have you. So none of a chocolate bar, half, a whole one. 0, 1/3, 2/3, 3/3. 0, 1/4, 2/4, 3/4, 4/4. One thing just to spot from this is how 2/3 is the same as 4/6, is the same as 6/9, is the same as 8/12. So we have there some fractions that are equal value, 2/3 and 4/6, 1/2 and 2/4. Okay, come back to that. There are quite a few things that we need to be able to do with fractions, but let's just see what we come as we go through the slides here. First of all, fractions are organised into families. So here's a family of fractions, 2/3, 4/6, 6/9, and so on. They all look different, but the key thing is 2/3, 4/6, 6/9, 8/12, 10/15, and so on. They have the same value. They are worth the same. All members of the family look different, but are related because they have the same value. They are equal value, or if you like to use the word equivalent, which means equal value. So this means, for example, here. What happens with equal value fractions is to get from there to there you times by 4. So if you do the same thing to this number here, so multiply that by 4, multiply that by 4 as well. As long as you multiply top and bottom by the same number, you will have another member of its family of the same value. So times by 5, times by 5. So here we're timesing by 10, so we times that by 10 as well. So the missing number there is 20. That kind of idea. Right. As far as comparing fractions and adding them and subtracting them goes, in maths you can only compare, add, subtract things that are alike. So you can compare, add or subtract 2/5 and 3/5 because they're alike. So clearly 3/5 is greater than 2/5. You can add them. 2/5 add 3/5 would make 5/5. You can do a subtract. 3/5 take away 2/5 is 1/5. However, you cannot compare, add or subtract these two because they're not alike. It's not necessarily immediately obvious which is bigger, which is the larger of the two, unless you first make them alike using a ratio table as an example. That's my preferred way of doing it. So 2/3 is equal value to all the other members of its family, and 3/4 is the same value as all the other members of its family. So what we want to do now is to find one member from each family that is alike to a member from the other family. So here in bold we have 8/12 and 9/12. So 2/3 is worth the same as 8/12. 3/4 is worth the same as 9/12. Now we know that that's the same as that and that's the same as that. It's now easy to see this one is greater. So 3/4 is clearly greater than 2/3. If we're asked to add 2/3 and 3/4, we can't do it the way they are. We have to convert them both into 12ths. So adding 2/3 and 3/4, we have to add 8/12 and 9/12, and we'll get 17/12. And if you want to do a subtract, then 9/12 take away 8/12 is 1/12. That's the answer to these if we wanted to do a subtract. Right. What else we need to do? If you want to find 5/8 of 32, we first need to find 1/8 of 32. That is, however you want to think of it, that's going to be £4. And then you want to find 5/8. So it'll be 5 lots of £4. It'll be £20. There's an example on that. Top heavy fractions, that's 9/4. So that's 9 lots of a quarter. So it's 2 1/4. So that's a top-heavy fraction there. This is a mixed number. And the one other key thing we have to be able to do is to multiply fractions. So that means 3 lots of 4, we know that. 3 lots of a half. So 3 lots of a half would be 1 1/2. What this means is a half lots of a half. But actually we normally tend to say half of a half. A half of a half we know is a quarter. We know a half of a half is a quarter. So if you want a quick rule for multiplying, the quick rule is that you multiply the two tops and you multiply the two bottoms. 1 times 1 is 1, 2 times 2 is 4. So what's going to happen here, for example, is to multiply these two fractions, you'd multiply 3 times 4 to get 12, and 4 times 5 to get 20. If you're being asked to multiply a mixed number, rewrite that first of all as being 3 over 2. Then we have the idea of reciprocal, which is where you flip a fraction upside down. So 2/3, the reciprocal of 2/3 is 3 over 2, for example. And then you have questions like this, sort of like dividing. How many halves are there in 2.5? So you may want to form some sort of mental picture there. How many halves are there in 2.5? The answer is 5. There's some more questions. I think that will do for now. Thank you.